Okay, this demonstration is going to be on calculating resistance in a parallel DC circuit. Pretty simple one. We only have two resistors in parallel. We're going to talk about the different formulas that you can use in order to calculate your resistance in a parallel circuit. The first one that we're going to talk about is your R total is equal to R divided by N, and what that is for is when all of your resistance values are the same. So if you had three resistors that were all 12 ohms, you could use this formula. Let me demonstrate. So in order to calculate your R total, the R divided by the N, so the value of the resistance divided by the number of resistors. I said that all three of the resistance values were 12 ohms divided by three resistors. That's how many are in the circuit. And that will give you a total opposition to current flow of 4 ohms. So that's when you can use that formula, is when all of your resistors are the same. If they're not, you can't use that one. The next one is the product over the sum. Now the product over the sum is okay for a circuit like this one. You only have two resistances, and it would be exactly what it sounds like, the product. So R1 times R2 divided by R1 plus R2. If you have more than two resistors in a circuit, you can still use the product over the sum, but you have to combine them more than one time. You have to keep repeating the steps using the product over the sum. So if we had a third resistor, you could combine R2 and R3 using product over the sum, and then once you have that value, you could combine that one with R1 to get your total. So your steps can get kind of drawn out on that, and the more steps you take in that, the more chance you take of making a mistake. So it brings us to our last formula, which the base formula is 1 over RT is equal to 1 over R1 plus 1 over R2. So it's the reciprocal of the R total is equal to the reciprocal of R1 plus the reciprocal of R2. Or you can simply isolate the total resistance by placing the reciprocal over the reciprocal of R1 plus the reciprocal of R2. It's really not that tough to do this, and it can be punched into your calculator all in one shot. So if we're going to calculate this one using the reciprocal, which is the one that I prefer, R total is equal to 1 over R1 plus 1 over R2. Go ahead and plug the values in there. So we have the reciprocal of 1 over 18 plus 1 over 12. So you punch that all into your calculator, and your total resistance is 7.2 ohms. Now, in order to calculate that and punch it in your calculator all in one shot, on the Texas Instruments TI-30X, there's a reciprocal button that is right above the number 7, and it is an X with a little -1 next to it. And how you punch that in, that would be 18, and then you hit that little button, and it's going to put up a little 1 right next to it on the screen. Or I guess a little -1 right here for the reciprocal. And then you can hit plus 12, and then hit that 1 over button, or your reciprocal button again, and it'll do the reciprocal for you in the calculation. That's the nice thing about using these calculators, is that they're pretty smart. So when you hit the equals button, it's going to come up with a really small number, and it's 0.1388888, so forth. But you don't need to, it carries it out about 10 places, and you don't need to do anything beyond that point. All you need to do now is hit the reciprocal button one more time, which is again the button right above the number 7, and it automatically throws that answer in there for you, and then it'll say ANS, which is the answer, or the reciprocal of the answer, which is that 0.1388888889, and then it equals one more time, and it should be 7.2 ohms. Okay, so you could add in 2 or 3 more resistors all using that same reciprocal button and just keep adding them on and keep going, and you'll still end up with the appropriate answer. One thing that needs to be said about the total resistance for a parallel circuit is that unlike the series circuits, the total resistance is going to be less than the smallest resistor. So this is a really important rule to remember. So R total is less than the value of the smallest resistor. So in the circuit that we have here, the smaller of the 2 resistors is 12 ohms. Your total resistance cannot be larger than 12 ohms. If it is, the calculation was not done correctly. So let me finish that. Less than the value of the smallest resistor. Now, just like with the series circuits, one of the things that can help you with a complicated circuit is to redraw it. And if you were to redraw this circuit, just like in the series circuit when you have 2 resistors combined, the ultimate goal is once again to get one equivalent resistor in series with the power source, so you can calculate your totals. Well, now that we've calculated R total, we could continue on from that, and we will. But the R total in this case is 7.2 ohms.